Hello there, my name is Will Patillo, and this tutorial video is actually based on a request to make a head tracking system where the hands are held, where the eyes can be held by your hands, kind of like in Real Monsters or in that really creepy monster in Pan's Labyrinth. This actually turned out to be a lot harder than I expected because Steam VR likes to just take control over the cameras and refuses to let go of them and will control whatever camera you put in the scene, which got very frustrating and is not how I would have designed things, because you never take control away from the user. But rants aside, let's get into how to build this. First, I'm just going to show you what it looks like. I have a scene fully built. So right now I'm holding the headset, I'm swinging it around, and there's a little bit of motion, as you can see in the scene, but not a whole lot. If I were to put the headset on, I would be seeing exactly what you're seeing in this game window, but I'm actually just going to leave my headset on a little cushion over here because this mechanic will make you motion sick. I don't really recommend using it, to be honest, after having built it, but the process of making it teaches a lot of things about how Unity works, so I think this will make a good tutorial nonetheless. So anyway, the first part of it, as you can see, is I've decoupled the tracking on the camera from the head display, and second, and more interesting, if I can take one of my hands and just put it inside my eyeball right there, I can pick it up and now I can be walking around, and that's whether I'm with a headset or whether I set the headset aside. Can just move and rotate my hand, look around by turning my hand, and if I want I can drop the eyeball. Now it's fallen on the ground. I can try to find myself. Let's see if this is a little tricky, as you can imagine, if you're just an eyeball on the ground and you're trying to see where my hands are. Okay, there's a hand. Let's see, move it in, pick myself up again, and then also, just to finish this off, I can throw myself, and now I'm off rolling away. If I check this in the scene view, what's going on right now, there's where my hands are. Let's see, where is my, yes, and here's where the camera is. And you could see, if I was looking at this from an external perspective, here's a large eyeball right there. There's the scene with my points of reference. And yeah, that's how it works. It's not working 100% the way that I would like because there's problems with rotation where Unity just throws in this random anchor point that causes your position to get all out of whack whenever your rotation isn't 0, which was kind of frustrating to deal with. So I've chosen to just leave the rotation as 0 whenever it's not being held by the hand. I'll have an option later in, which I've also commented out, where you can change the rotation. It's just it screws up the position, so you can decide which you prefer. And also, not being able to work with rotation a lot prevented me from adding in other features, such as being able to press the grip button, hold it, and have your eye look around even when you're not picking it up. But once we get through all this other stuff of building this scene, it should be fairly clear how you would do that, assuming you're able to fix the rotation problem. And as you can see, I have a completely blank scene. I'm starting from scratch. As with almost any VR project, I delete the main camera, go to the asset store, look up Steam VR, get this handy Steam VR plugin, import it. Okay, so I just click through all the prompts and that. Shouldn't be anything you need to worry about. Go into your prefabs, and again, this is the same as pretty much any VR project. Take your Steam VR, drop it into the hierarchy. Also a camera rig, make sure it's at zeroed out and is at a scale of 1. Next, I'm going to create a few points of reference for the scene. So let's start off by creating an empty game object. I'm going to call it environment. And inside of it, I'll create a ground plane. Let's make it 10 by 10. And that's a little hard to see right now, so I'm going to create a new folder, call it materials, and I'm going to create a new material, call this grass, get a quick color here, let's see, drop this down, okay, that looks fairly nice, put that in place. Okay, and I can see that's a little high up, so it's intersecting. It's because my environment is not at 0. Great. Okay, now that's flush with the ground. That's good. A couple other things I'm going to put in place here. Let's see, I'm going to create a little pedestal. Let's see, 1.5, 0.3. Raise this up. Actually, I'll drop this down to 1. Put that at 0.5. And move this back here. Okay. Create another material. Call this wood. Drop around about here. Get a kind of reddish color. And there. And feel free to mess around with this if you want it to make your scene look nice. And I'll just add one more object. Create another cube. I'm just going to place this out here. I can leave this one as being white. Actually, put this at 2. And the idea of this is just creating a little point of reference so I can see where I'm facing. If there's just a big field of green, it's hard to know whether or not you're moving. And I'll just leave that as white for now. If you want to place some more boxes and things around, that is up to you. I'm going to save the scene. I'm just going to call it main. That's good enough. Okay, and create a new folder for scripts just to get things going. All right, so that's where I'm starting. Next, go into my camera rig and pull this camera head outside of the camera rig. It'll be helpful later, and that's fine if it breaks the prefab instance. Next, I think we'll start getting into some of the actual scripts. So there's 3 that I'm going to need for this project. One is our main script, which I'm going to call Untracked HMD, something nice and generic. And this is what's going to decouple the camera from where the head-mounted Steam's or the Vive display actually is. And I think the same process will work for Oculus as well. Unfortunately, I can't just use the main camera instead of this one and assume that it'll work, because once Steam is in the scene, and that's even if I disable the camera rig and Steam VR, like as soon as I've imported it, Steam's just going to take over any camera I put in there and take away my control as a developer. So we're going to have to hack it a little bit to work around that limitation. So that's what Untracked HMD will be about. It's also going to deal with some of our picking up and dropping the camera as well. Next, create another script. Call this controller input. This will just get controls from the Vive's hand controllers and then pass that into other scripts so that they know what the player is doing. And then one more script, which I'm going to call iTouch. And this is for detecting collisions, essentially, and knowing when the player's hand is touching their eye so that it knows when it can pick it up and when pressing the trigger doesn't do anything. So let's start in on Untracked HMD. Feel free to open this in Visual Studio or MonoDevelop, or whichever you need. I'm going to get rid of these two libraries as I'm not going to be using them. Transform.position, local position equals cam dot, hold on, no autocorrect. Okay, fine, I'll have to declare some variables. All right, so camera cam, and in start cam equals get components in children camera. I'm going to want a vector 3 rest position. We'll get around to actually using this later. I just want to get some of these variables declared so I don't get that annoying autocorrect issues again. Let's see. iTouch, this is a reference to our eye grabbing script. Rigid body, IRB, so that when we throw the eye around, it's able to use physics. So transform.local position equals cam.transform.local position. Okay, and transform.rotation equals quaternion.inverse cam.transform.local rotation. Create a new empty game object. Just put that out here in the scene. And I'm going to call this negate tracking. And make the camera a child of this negate tracking object. And this untracked HMD is going to go here. So essentially the way this is working is I can't prevent this, which the eye camera is attached to, from tracking the head. Steam is just not going to allow it. So instead, I figure out where its position and rotation is and take the inverse in the case of rotation and the opposite in the case of position and just add that to here so that the position and rotation of negate tracking cancels out the position and rotation of the head so that it ends up just being, for now, just at 0. And then next we're going to add in a rest position variable that allows you to offset so that it's able to follow, say, such as being on top of this pedestal, being in your hand, being on the ground, wherever it needs to be. Also make sure that this negate tracking is at 0 to start with. Get everything all nice and lined up. And for now, I'm just going to leave it on the ground. So let's see what it does so far. All right. Okay, it's way off over there. what's going on? So what I left out was actually I need this rest position right from the beginning. So in start, I'm going to add rest position equals transform dot local position. So okay, so I get the location where this object is at the very start when I hit play, and then on this transform dot local position, I'm going to make that be rest position minus cam.transform.local position. Okay, so I found the problem here. It's actually wasn't an issue in the scripting or in the scene itself, and actually this rest position wasn't really necessary just yet, but I'll leave it in because it's gonna come back. The thing I need to add so again, the problem is that it's getting some rotation on me when I swing the head around. To prevent that from happening, I go into this camera eye object here and add a component called tracked pose driver. I'm going to select that, and then under tracking type, I'll just go to position only. And I think that's the only thing I need. Just for a little bit of safety, I'm going to add my pose source to the center eye and make this on update only. And run that. Now, as I can see, as I'm moving my head around, the scene view is not moving. Currently, the camera is just sitting here on the ground. I'd like to have it start on top of this pedestal, which adds a little extra challenge of it not being at 0, 0 all the time. So I've done most of that work already with this, creating this rest position variable, where I just find out where it is on start, and then I set my position to the rest position minus the tracking effect. Take this negate tracking variable and just move this back and up on top of this pedestal here. Let's see, camera's getting in the way, so I'm just going to get rid of that gizmo. And over here, let's move this a little forward and down so that it's just on top of the pedestal. So let's see if that works. Great. Okay, now I'm resting on top of the pedestal and again, not tracking. Next, I want to work on creating an object right here that will be sitting on the pedestal that this camera is going to be aligned with, that the player can pick up with their hands and move around. So to start with, I'm going to create a new 3D object, be a sphere, and I'm going to call this eyeball. Put that up here, and this is going to be a physical object, so it's going to need a rigid body. Use gravity, is not kinesmatic. Yeah, all those things by default are fine. Let's get this in a nice position here. I'm going to bring this, it's kind of big for an eyeball, so I'm going to make it down to 0.1. Move this on top of the pedestal, which I believe was at -1 and +1.1. Let's see, move it back down a little. Okay, so that it's resting on top of that pedestal there. Okay, good. And this eyeball is going to receive the eye touch script so that it knows when it's getting the hands. Next, on this left and right controller, I'm going to attach the controller input script. Below the controller, I'm going to take a 3D object and create a sphere. Let's see, I'm going to shrink this down to 0.1. That looks about big enough. Get rid of the mesh renderer. I could have just created a sphere collider. Would have been fine. Add a rigid body. Turn off gravity is kinematic. And let's see, make sure doing this right. And they are triggers. Otherwise, if the hand hits the eye, it'll just knock it off the pedestal, which you might like, but it's going to make it kind of hard to actually pick the thing up. And I would rather use knock aside and pick up in a separate grab objects tutorial, possibly in the future. Okay, and its radius at 0.5, that should be fine. I'm going to call this the sphere hand collider. Actually, make it the left hand collider. Now I'm going to duplicate that, put another one on the right hand, and call this one right hand collider. Okay. And these are not going to need any scripts attached to them. Now on this eyeball, on this eye touch, get rid of these two libraries because we don't need them. And start with a, let's see, we don't need update. We will need start. So first, private void on trigger enter, collider other is fine. And if other dot game object equals left hand, and I'll define that in a moment. So how this is going to work is it's going to detect whether there is a hand in the eye or not. That way, in a separate script, when the player presses the trigger or doesn't, it'll know whether to react to that. So hand in eye equals left hand. And then repeat for the right hand, else if right hand, right hand. Now let's go ahead and define what these terms are. Take a serialized field, game object, left hand, right hand. Assign those. So let's see, we got the eyeball, eye touch. Oh wait, no, error. Oh yes. Also public game object hand in eye. Get rid of those errors so we can assign some things. Okay, so take my left hand and my right hand. Private void on trigger exit. If other dot game object equals hand in eye, then hand in eye equals null. we'll be adding more to this in a little bit later. So let's see if this works. So I'm going to be watching this hand and eye variable right here. What should happen is that when I take my hand and the collider touches it, that variable should populate with something. Ah, there it is. I can see in that hand and eye it says right hand collider. And when I take my hand away, it says none. It's a little bit finicky, and I can deal with that by just making the collider a little bigger. So let's take a look at that. Okay, that's actually not a bad size, but it's not centered particularly well. So let's say if I move down on the y-axis by about -0.05. Okay. So let's see. Good. Actually, that one might have been a little far, but it's the right direction. So I'll just set that to 3. Now it should make the eye a little easier and more intuitive to pick up. Okay, let's stop on that and go into the controller input script, which again is attached to the left and right hands. Private Steam VR tracked object tracked obj public Steam VR controller dot device is device. Then on start, we'll say that tracked object equals get component copy paste Steam VR tracked object, and there we go. Then so there gets our reference there. Then in update device equals Steam VR controller input int tracked object dot index. If device dot get press Steam VR controller dot button mask dot trigger, then oh yeah, I'll need to get a reference to my untracked HMD, so I'm gonna add that here. Serialize field untracked HMD tracker. Okay, now that I have a reference to this script, I can say tracker dot on grab, and I'll pass in the transform of this controller. Else if copy this, get press up, then it is on drop. We'll leave it at that. I'll leave this empty for now. Add those functions into here. So public, because it's being accessed by a different script, void on grab, transform, and hand. Public void on drop. No arguments yet. Next, this is going to get a reference to the eye. It's going to detect whether or not there is a hand in the eye, and if so, it will say that the grab was successful, and then attach the camera to the tracked hand. And if it's not, if there is no hand in the eye, then will ignore it. Public game object eyeball. And now I'm going to be getting this eye touch here. Eye equals eyeball dot get component eye touch, which allows me to be able to say if I, which again is this here, dot hand in eye is not equal to null. For now, we'll just say put in a little debug log. Debug.log grabbed eye with hand.gameObject.name. Just a little test to see if this works. Okay, and also I think this should probably be a get pressed down, so it's not firing every single frame. All right, let's see if that works. Oh, no, didn't assign some things. Ah, yes. So on this negate tracking, I have this eyeball reference, and I'm going to toss it in there. Left and right hand, I need to assign this tracker script. Try that again. Okay, put my hand inside the eye, press grip, and I get a console log saying grabbed eye with controller right. Now, one thing I suppose I think that would happen right now is just a little bit of a bug, which I think I'm going to fix right now. Not a big deal. Let's say I put one hand in, and it is, so I have my left hand controller here, and I press with my right hand. It says that I grabbed the eye, which would mean that I'd pick it up when I'm grabbing with my other hand, which doesn't seem right. So I'm going to change this from just looking for a null. So if hand and eye is equal to hand dot get child one dot game object. I'm going to test that to make sure it doesn't work, to have a little bit of an insight as to why. Okay, so I bring my hand in, yes, and it's managed to grab with the right controller when that's in there, and then likewise, if I press the left controller, it tries to grab but does not succeed. Okay, that's a good way to make sure that I'm grabbing with the correct hand. Remove those little debug log lines. Okay, now for the actual attaching the eye to the hand. Getting to what we're really going for this whole time. So, say transform dot set parent hand. And on drop, if I dot hand in I, and this one I'll just keep things a little simple and just say not equals null. Transform dot set parent. This time it is null. So in this I touch start hand in I equals null, just so there's always some kind of value in here. What's happening here is that as I move my hand around, the controller isn't entirely in sync with where the camera is. So very often, even though I'm continuously holding the eyeball, it's gonna lose contact and fire the on trigger exit command here, setting hand and eye to null. So what I'd like to happen is, as long as the trigger's pressed, it doesn't matter where my hand moves relative to the eye. Basically kind of ignore the on trigger exit. But instead of ignoring it, I'm just going to work around it by adding in my Untracked HMD a public boolean is held. And now on my eye touch on the on trigger exit, if tracker dot, need to create a reference for it so it doesn't get angry at me here. Serialized field untracked HMD tracker. If tracker dot is held, then return. So that way hand and eye will never be set to null as long as the eye is held. And there may be a cleaner way of doing this, but this will work. Also just add in a debug line saying it dropping eye. Touch tracker drop in negate tracking. So on grab, I want to say is held equals true, and when I drop, then is held equals false. Yeah, adding that variable in doesn't really do much if I'm not actually setting it. Okay, take the hand, bring it here, pick it up, move over, let go, and negate tracking goes right back to its starting point with its parent as null, which for now is what I want it to be. Okay. So the next thing is I'd like, when I let go, rather than just returning to our starting position, to fall to the ground. So for that, I'm going to actually need to make a little more use of this eyeball model. And what's going to happen is that whenever I'm picking up and moving the camera, this physical object is going to follow the camera and be on top of it. When I'm not holding the camera, or not holding the eye, and say I let go, then the camera is going to be following this eyeball object, while this just follows its own laws of physics and falls to the ground, rolls, gets thrown, whatever. So I'll get started on that now. And this will also make use of this is held. So on my update function here on my untracked HMD script, if is held, then, actually, no, that's not right. If is held, then it's going to be doing something else. If it's not held, then we're offsetting based on the position of the HMD. If it is held, then we're going to be updating its rest position to equal that of the location of the eyeball. So if is held, rest position equals transform dot parent dot position. So that way it's the place where it offsets to when it's not held is updated as the hand that's holding it moves around. And then eyeball dot transform dot position equals rest position. So again, rest position is just kind of like a saved offset, and then I'm going to have the physical mesh of the eye with its rigid body and all that stuff following that saved position. Update this else case a little bit. So again, if it's not held, then the rest position is going to equal eyeball dot transform dot position. That way, if the eye's rolling around on the ground and it isn't being held, then the camera's offset is going to follow that motion. Let's see what this does. So not really making much use of physics at this point, I don't think, but okay, so I pick the hand up, I move it over, and I let go, and I'm falling through the earth. Essentially what's happening though is it's immediately going to the ground and continuing to fall from there, and it's not detecting the collision with this ground plane. So if we fix the problem where it immediately drops to 0, then we should also fix the problem of it falling through the earth. So the way to deal with that is to actually make use of some of these rigid body elements on the eyeball. So I declared this variable rigid body IRB. I'm going to actually assign that now. IRB equals eyeball dot get component rigid body. All right. And now that I have assigned it, I can mess around with some of the rigid body's variables. So when I grab, I'm going to turn off the gravity. And technically this isn't strictly necessary because I'm constantly updating its position to be where the hand is. So although it was using gravity before, it was being held in place. Nevertheless, I think it's a little cleaner to just have gravity off if I'm not using it. So, and then here on drop, I turn the gravity right back on. Also, if hand and eye is not equal null, and I've just dropped. I'm also going to set I.hand in I equal to null. Yeah, just to make sure that my variables are set correctly and there's no or limited amount of unexpected behavior. Let's test that again. Okay, take my hand, pick myself up, move over a little bit, let go, and good. Yeah, I start falling from where my hand is and drop to the ground. And if I take a look at the scene view, I can see that I've moved a little bit away from the pedestal. So one other thing I'd like to have here, this is getting a little bit more into the smaller details, is remember if you're reaching your hand in and picking yourself up, you don't want that controller just taking up your face and blocking your view. So I'm going to say that whenever you're picked up, then the model of your hand will disappear. And then when you drop, that model will reappear again. So that way it's never blocking your view. Also, I'm going to turn on and off the mesh renderer of the eyeball itself in case it ever doesn't track quite right. You never have this big white sphere occluding your view either. Renderer eye model, and then eye model equals eyeball dot get component renderer. Get our reference to it right there. Set that up. Also on the controller input, in addition to passing in the transform, I'm also going to pass in the game object, pass in the hand model so I can turn it on and off. So let's see, this is getChild0 in both cases. Actually though, what I think I'm going to do instead, because I don't really like using getChild because that can get screwed up when you change things around in your project. So I'm going to go into my controller input. Oh, and since I haven't done this already, get rid of those libraries again. Serialize field, game object, and hand model. And then on and grab, I'm going to pass in that hand model. I'm also going to pass in game object hand model for on drop. Now since I've added in arguments, I need to update these functions to be able to receive them. So game object hand model, and once again on drop, game object hand model. Should get rid of those errors. Game object is a type. What? No, that. Oh, right. I don't need to define the type when I'm passing in an argument, just when I'm receiving it. Okay, those are in place. I can go into my scene. This hand model should show up. Just drop in that one over here, and then this one over here. Okay, now that I have that information, I can go in here and actually make use of it. So when I'm able to drop, I'll just say hand model dot set active false, and then over here hand model dot set active true. That should cause my hand to disappear as soon as I pick the thing up. Also, to turn off the renderer for the eye, just say iModel dot enabled equals false. And the reason for that, I use set active for one, is because with these models I'm just unchecking the entire game object, whether it's active. With the eyeball, I'm keeping it active the whole time, but just turning off, on and off, this component. So iModel.enabled is false, and iModel.enabled equals true. All right, let's test that out. Make sure I didn't forget to assign anything or other little errors like that. Pick myself up, and notice I cannot see my hand. I can also notice that the eye is turned off. If I look in the scene, I can see the controller that's on the ground, but not the one that's holding the eye or the eye itself. Then if I go over here and I let go, now the hand's visible, the eye's visible, and we're all good. All right, next thing I want to add, another detail of a little bit of polish, is being able to throw the eye. Right now, for example, if I pick myself up, let's see, go here, and I swing my arm and throw, I just stop as soon as I let go of the trigger and fall straight down. That's not particularly interesting. So to get a nice throw in here, I'm going to, in my onDrop variable, I want to also pass in a throw velocity. So let's see. So here, in addition to hand model, I'll pass in device.velocity times throw force. Throw force is going to be the serialized field float throw force, and this isn't technically necessary. I could leave this out, and then it would throw with a velocity of whatever the velocity of the hand is, but this allows me to give a bit more control and be able to throw farther with the same amount of effort. And I'll set that in the inspector in a moment. Then I go back to Untracked HMD and be able to receive this argument. So on drop, I have that, and also it takes in a vector3 throw force. Actually, I'm going to call this throw velocity. Okay. And now right here on this, where I set the IRB's use gravity, we say IRB dot velocity equals throw velocity. Okay. Should be all I need for there. And let's see if I'm able to throw myself now. Okay, take my hand, reach in, grab, throw, and nothing happened. What's going on? Oh, right. I know what the problem is. It is that on my left and right hand, my throw force is still 0, which means it's negating all of that. So I'm going to put in 1.5, and feel free to experiment around with different variables. I find 1.5 gives a pretty satisfying amount of force in this particular case. Pick myself up and throw, and away I go. And for whatever reason, I fell through the plane. That's okay. probably a collision detection issue. I think I can fix that if I just set this to continuous dynamic. So that is everything. Now, the one thing I'd like to do before finishing off this tutorial is experimenting a little bit with applying the rotation from when you let go to when the eye isn't following the hand anymore. So if I pick up the eye and turn my hand so that it's facing, say, off this direction to the left, that I'll still be looking over there. In fact, to make this a little clearer, I'm just going to put another point of reference. So I'd like to be able to drop the eye and look at this cube over here. So I can tell them apart. I'm going to add some more materials and make this one red. Let's see, 0, 0. And then take another material, make it blue. And drop that on this. And okay, so right now, every time I let go of the eye, I'm going to end up facing in the direction of this cube. I may have moved, but I'll always be facing this direction. I'd like to be able to face this direction or any other. So there is a way that I can get that partially working, but it causes problems with the positional tracking. And if anyone else can solve this, I would be very interested in seeing how that works. But at least so you can see what the challenge is, I'm going to add a little bit more code here to my Untracked HMD script. So right next to rest position, I'm going to add a quaternion rest rotation, or rest rut for short. Now, rest position is that, and rest rotation equals transform.local rotation. So initializing it, not strictly necessary because I'm starting out facing at 0, 0, 0, but this way I can start in a different location, in a different rotation, at least theoretically. Next in my update, if I am held, now my rest rotation equals transform.parent.rotation, and else transform.rotation equals rest rotation. So that way, whenever I'm being held, I'm updating my saved rotation, and when I'm not being held, then I'm setting my rotation to that saved value. And since I'm using this, then it's not going to be this quaternion.inverse anymore, which is going to cause problems since I'm not offsetting anymore, but you'll see that in a moment. And then everything else should be the same. So I'm going to go in. Starts off, no problems. Yeah, there we go. That's a good example. So you can see here, I'm looking in a different direction, and it's being saved, and it's following that. But now my point of view is no longer aligned with the location where I want it to be. And I think the reason for it is relating to pivot points. I'd like the pivot point to be in the object that I'm following. But because we're dealing with all these offsets, where the pivot point actually is probably something to do with how far away my headset is from the center of the screen, or from the center of the play space. And so that's, and since it's not pivoting around the actual center, rotation causes it to move from here all the way around in all kinds of crazy directions. However, we have something that works to a limited extent, and in the process got to experiment around with hacking a little bit of the HMD and how that works. Some other things to know about that I came up in the course of researching how to do this but did not make it in to the actual process is changing some of these settings. If I go here and set this to main display, that's actually another very easy way to turn off tracking, because then it just follows wherever the camera is and doesn't even take into consideration where the head-mounted display camera is. The problem is that if I do things this way, then it's not using really the headset anymore. It's not actually updating to the eye. So you didn't see that, but if I started at none and then hit play, my headset's actually blank. And if I set it after I hit play, it'll show something in the game, but it won't update when it moves around. So that was kind of a dead end in terms of building this sort of thing. I'll also be posting this project along with the code up on GitHub, so that's on a public repository, and we'll include a link to that repository in the description below this video. So if you ever get stuck, or you just want to grab the code and not go through a long tutorial to build it step by step, then feel free to grab it there. It's all free. If you enjoyed this video, feel like you learned something from it, don't forget to hit those like and subscribe buttons. And until next time, I'm Will Patillo, signing out.